The ground begins to tremble. Windows rattle. A deep, rolling sound rises from beneath the surface. In just 30 seconds, buildings sway, streets crack, and lives change forever. This is what happens when the earth roars, when the forces hidden beneath our feet remind us how fragile the surface really is. Earthquakes are sudden. They arrive without warning. They strike when immense pressure built deep within the planet finally breaks free. Beneath us, the Earth's crust is divided into giant pieces called tectonic plates. They move slowly, just a few centimeters a year. But when these plates grind against each other, energy builds up over decades, even centuries. When that pressure is released, it sends shock waves through the ground. Seismic waves that ripple outward from the point of rupture. We call that point the focus. The spot directly above it on the surface is known as the epicenter. And when those waves reach us, the world begins to shake. Imagine this moment. It's a calm morning. People are at work, children are in school, traffic hums through the streets. Then, without warning, the earth shifts. At first, it's a faint rumble, a vibration that feels like a truck passing by. But within seconds, it grows stronger. Hanging lights swing, car alarms blare. The floor seems alive beneath your feet. Now the shaking becomes violent. Walls crack, glass shatters.
Power lines spark and fall. People dive under tables trying to protect themselves from falling debris. The sound is overwhelming, a deep, continuous roar mixed with crashing metal and breaking stone. And then, almost as quickly as it began, it stops. Dust fills the air, sirens begin to wail. People step outside in disbelief, looking at the damage around them. 30 seconds have passed, but those seconds will shape lives for years to come. 30 seconds may not sound long. Yet, in that time, entire buildings can collapse. The ground can move several feet in opposite directions. Bridges can twist. Cities can fall silent. Scientists measure earthquakes using the moment magnitude scale, a modern version of the old Richter scale. Each number on that scale represents about 32 times more energy than the one before it. So a magnitude 7 earthquake is not slightly stronger than a 6, it's 32 times more powerful. The strength of the shaking depends on 3 things: how close you are to the epicenter, how deep the quake occurs beneath the surface, and what kind of ground you're standing on. Soft soil can amplify shaking, while bedrock can help dampen it. But shaking is only the beginning. Earthquakes can trigger fires, landslides, and even tsunamis if they occur under the ocean. In 2011, Japan experienced one of the strongest earthquakes ever recorded, magnitude 9.0. The shaking lasted 6 long minutes and unleashed a devastating tsunami that destroyed entire towns. More than 18,000 lives were lost. Even shorter quakes can be catastrophic. In 1994, the Northridge earthquake in California lasted only about 20 seconds, yet caused billions of dollars in damage. Every earthquake tells the same story. The length of shaking doesn't always predict the destruction. What matters most is where it happens and what stands above it. For those who live through it, the memory never fades. There's no warning, no siren, just the sound of the world breaking apart. People describe it as if the ground became alive, rolling, twisting, roaring. It's confusing, disorienting, and terrifying. That's why preparation matters. Simple actions save lives. Drop to the ground. Take cover under a sturdy table or desk. Hold on until the shaking stops. Stay away from windows and heavy furniture. If you're outside, move into the open. If you're driving, pull over and stay inside your vehicle. After the main shock, expect aftershocks. They can come minutes or hours later, and sometimes are strong enough to bring down weakened buildings. But what actually makes the Earth roar? When a fault line ruptures, energy travels through the crust as waves. The fastest are called primary waves, or P waves. They compress and expand the ground, much like sound waves. Then come the secondary waves, or S waves, which move the ground side to side. Together, they make the surface ripple like water in a pond. When those waves reach cities, buildings and objects vibrate at different frequencies. The sound of those vibrations, metal groaning, glass breaking, concrete cracking, creates the deep rumble we hear. It's not the Earth itself making noise. It's everything on top of it reacting to the movements below. In that sound, we hear power, the release of energy that's been locked away for hundreds of years. 30 seconds. That's all it takes for the Earth to remind us of its strength. Every earthquake is a message from the planet that the crust beneath our feet is alive, shifting, and changing. We can't stop tectonic plates from moving, but we can learn. We can prepare. We can build smarter and respond faster. The Earth will continue to move. It always has and it always will. The question is not whether it will roar again, but whether we'll be ready to listen.